ทุกคนผู้ที่ปวดเมื่อยกกระดูกและข้อไม่ว่าจะเป็นมา10 ปีหรือ20 ปีลองฟังฉันครั้งนี้นะเพียงดื่มโอเมชัววันละ2 แก้วเท่านั้นให้ผลลัพธ์รวดเร็วบรรเทาอาการปวดเมื่อยลดการเสื่อมสภาพเอาความอิสระกลับมาปลอดภัยและประหยัดทุกคนรีบโทรสายด่วนบนหน้าจอเพื่อรับส่วนลดสูงสุด 40% และรับคำแนะนำฟรีจากผู้เชี่ยวชาญด้วยนะ
ใช้มาได้3 เดือนแล้วครับลุงสามารถยืนขึ้นแล้วก็นั่งลงได้ด้วยตัวเองขึ้นลงบันไดอย่างสะดวกเลยมือและเข่าเนี่ยไม่มีอาการชาแล้วก็บวมอีกต่อไปชีวิตกลับมาเป็นปกติเหมือนตอนหนุ่มๆอีกครั้งหนึ่งเลยครับลุงสามารถกลับมาออกกำลังกายกับเพื่อนๆได้เลยร่างกายแข็งแรงอย่างเห็นได้ชัดเลยครับนมอมาชัวยังช่วยประหยัดค่าใช้จ่ายได้มากเลยครับก็ต้องขอบคุณนมอมาชัวในที่นี้มากๆเลยครับ
มันยอดเยี่ยมจริงๆเลยครับอาการปวดข้อจากโรคเกาต์ของผมนะครับเพียงแค่ใช้โอมาชัวเพียง1 ชุดนะครับทุกวันนี้ผมยังดื่มโอมาชัววันละ2 แก้วครับแม้กระทั่งเวลาทำงานนะครับก็ยังต้องดื่มเลยตัวนี้ครับโอมาชัวทุกวันไม่มีขาดเลยครับ
ชัวเป็นผลลัพธ์จากงานวิจัยหลายปีของผมและผู้เชี่ยวชาญชั้นนำของอเมริกาซึ่งเป็นก้าวกระโดดที่สำคัญของวงการแพทย์โลกผลิตภัณฑ์นมธัญพืชโอมาชัวเป็นผลิตภัณฑ์แรกของโลกที่ใช้โปรตีนจากพืช 100% เพื่อสนับสนุนการรักษาโรคข้อกระดูกซึ่งได้การรับรองจาก FDA สหรัฐอเมริกาจุดเด่นของโอมาชัวคือการผสมผสานตามอัตราส่วนทองคำระหว่างนาโนเคอร์คูมิน 5% พร้อมกับส่วนประกอบอื่นๆ เช่น MSM อัลวาไทด์ซึ่งช่วยเพิ่มประสิทธิภาพในการลดความแข็งของข้อกระตุ้นการฟื้นฟูและการสร้างเนื้อเยื่อเพื่อกระดูกอ่อนอย่างรวดเร็วเพียงหลังจากใช้งานช่วงระยะเวลาสั้น
ๆป้าทานนมโอมาชัววันละ2 ครั้งเช้าและเที่ยงหลังใช้สัปดาห์แรกรู้สึกอาการที่ชาที่มือและแขนหายไปการยืดและเหยียดดีขึ้นทำงานได้สะดวกขึ้นหิ้วของอะไรก็จับได้แน่นขึ้นตอนนี้ป้ายืดแขนสูงๆอย่างนี้ก็ไม่รู้สึกเจ็บอีกแล้วนะคะป้าต้องบอกว่าเห็นผลเร็วมากด้วยเทคโนโลยีใหม่จากอเมริกาส่วนประกอบทั้งหมดเสริมด้วยแคลเซียมและวิตามินและมีข้อมูลทั้งหมดบนบรรจุภัณฑ์ที่ทุกคนสามารถอ่านและศึกษาได้หลังจากใช้ต่อมา1 เดือนป้ารู้สึกไม่ปวดเมื่อยแขนขาอีกต่อไปไม่รู้สึกเหมือนร่างกายถูกเข็มจิ้มอีกแล้วค่ะตอนเช้าป้าก็ลุกขึ้นได้เองรู้สึกตัวเบาสบายใจมากไม่ต้องให้หลานๆมาช่วยเหมือนแต่ก่อนรู้สึกเหมือนกลับไปอายุ 30-40 ปีอยากจะไปไหนก็ไปอยากจะทำอะไรก็ทำรู้สึกไม่เป็นภาระของครอบครัวอีกแล้วมีความสุขมากๆค่ะ
โอมาชัวมีประสิทธิภาพในการดูแลผู้ป่วยโรคข้อกระดูกอย่างลึกซึ้งด้วยความสามารถในการลดอาการปวดข้อกระดูกอย่างรวดเร็วปรับปรุงการเคลื่อนไหวของร่างกายและป้องกันการเสื่อมโรคข้อกระดูกพรุนอย่างมีประสิทธิภาพนอกจากการสนับสนุนการรักษาโรคข้อกระดูกแล้วโอมาชัวยังมีวิตามินและแร่ธาตุ21 ชนิดซึ่งช่วยเสริมสร้างสุขภาพโดยรวมต่อหัวใจและสมองการดื่มนมโอมาชัวอย่างสม่ำเสมอวันละ2 แก้วหลังจาก 2-3 เดือนจะทำให้การเคลื่อนไหวสะดวกและยืดหยุ่นมากขึ้นชะลอกระบวนการเสื่อมและโรคกระดูกพรุนทำให้ระบบกระดูกและข้อแข็งแรงด้วยความทุ่มเททั้งหมดของผมเชื่อมั่นว่าโอมาชัวจะเป็นทางออกที่สมบูรณ์แบบสำหรับผู้ที่มีปัญหาเกี่ยวกับกระดูกและข้อใช้โอมาชัวและสัมผัสถึงความแตกต่าง
Me some trouble. First of all, the stock wasn't straight to begin with, but I could bend it back into shape with some clamps. But then I picked the wrong drill bit size from the tapping set and now have M5 through holes instead of threads. What a bummer. I think this is still usable, I just have to use nuts on the other end now. Okay, we heard that, and 20 minutes later I recut threaded holes next to the OPC. Moving on. Now every plate needs a spacer block from wood or something. I found a perfectly suitable offcut from another project, cut it to size and drilled the holes. By accident, I got this perfect match of frame rate and RPM on the drill press, making it seemingly standing still. This looks weird, like just pressing the bit into the wood. And same with the chamfering bit. Recording this was pretty cool. Finally, chamfering the edges, and these pieces are done as well. With all these parts done, it's time for the first assembly. I start by joining the rails end to end with the big steel plate to make a long one. To align the rails, I use one of the blocks, slide that halfway over both rails, and tighten the bolts. Now this is by far not the smoothest of transitions, and definitely not the intended way of doing that, but for my camera gantry purpose, this should be fine. So far so easy. Now mounting all this to the ceiling. I first measured and marked the ceiling center, drilled one hole for the big steel plate and screwed it down, or rather, up. Then I could measure the distance from both ends to the wall and rotate the whole thing around the first screw to adjust it parallel to the wall. By the way, I did this whole installation together with my dad, some nice dad and son shop time. Next is securing the ends. We had a nicely questionable clamping setup to press the plate and spacer against the ceiling. It worked perfectly for starting the holes. And here it's essential for the holes not to wander and be at the exact location. In concrete, I found this works best to start the hole with a regular drill, then switch to the hammer function and then switch to a rotary hammer for the hard work. After securing the ends, we mounted the other steel plates the same way and finally the second center screw. And now this rail is up there for good. Ouch. 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 Also, this ceiling is amazingly straight. I didn't have to change any of the spacer blocks. And so the transition in the middle now is basically flawless. Next is making an aluminum plate to mount the two blocks to. I had some leftover bar stock big enough for this purpose. I just cut off the other project leftovers and cleaned the edge on the table saw. Then marking the hole placement and drill pressing them, you know. And after some more chamfered rounds and deburring, this part can be installed. I have another short but identical rail, so I don't have to do this over my head. From there I can slide it onto the long rail and test it out. Nice. Whee! Next I need to make a shaft. Everything else will hang and rotate around this shaft, so I want it relatively beefy and accurate. So it's on to the metal lathe, where I first face the end of some stock, center drill and drill and tap M10 threads. First time I tried power feeding this tap size. Pretty cool, but being a blind hole I finished by hand. I then cut it to rough length, leaving it long enough for proper work holding. The other side gets an extra big center hole drilled, so the live center still makes proper contact after I cut the M8 threads there. Then I chucked a piece for turning the diameter down and marked where to roughly stop. I want the hole length really accurate, so I better check the tailstock alignment by comparing the diameters at both ends. I see 2 100th mm variation. Not bad, but after a few adjustments I made it much worse and then got it to 5 microns variation and went with that. Then it's a bunch of hogging away material, but before the final passes and measurements I let the part cool down again and then sand it to my required dimension, which I undershot by 1/100th. Bummer. But I can account for that when I turn the bushings that will fit this shaft. So then I could face the shoulder to final length, add chamfers, and flip the part around to cut off the extra material and finish up this side as well. And there it is, a shaft. It now gets bolted to the aluminium plate with the blocks, but to better spread the clamping and bending loads this part will see, I also turned a thick washer which goes in between both parts. Let's do it properly. This M10 bolt needs 48 Nm of torque. And with that, the rail assembly is complete. So moving on with the boom arm assembly. This requires both wooden and machine parts. Let's start with the plywood parts that fit the shaft I just made. I cut the main shape of them with the CNC router, cause that gives me the best accuracy for the hole locations, and leftover hold-on material gets removed with the trim router. All done with unnecessary drawings. Now these pieces receive some bushings that precisely fit the shaft, so back to the lathe where I faced some more stock, drilled out some material with the biggest drill I have, and then turned the OD to a press fit in the wood with a little shoulder. I cut it off now, flipped it around in the chuck, faced this side and opened up the ID. I did it like that cause turning a through hole is much easier than a blind hole. When I got closer to dimension, I checked the ID with a telescopic bore gauge after every pass and again sanded to final fit. Another reason why I needed the through hole. Oh nice. Some deburring and the part is finished. Of course, I made 2 of them.
I pressed them into the wood, dry assembled the rest, and inserted the shaft to see if it still fits. Rubber bands seem to be the best option for clamping, as they clamp all parts evenly. With regular clamps, the parts shifted ever so slightly, causing the shaft to bind up. That didn't happen with the rubber bands. So then I did the same thing with glue, but using more rubber bands for more clamping pressure. The next day I could remove the rubber bands and test the fit again. All the holes are for reinforcement dowels, which I first drilled to depth and then glued all the dowels in. While that's drying, I can work on the wooden boom arm. I cut a slightly oversized piece from a bigger board, jointed one face and edge, and planed it to thickness until it fit the other part. The width I cut on the table saw, and then this goes together nicely. So let's take this for a test spin. Perfect. It rotates smoothly and clears everything. Now this boom arm needs some more work. I set the table saw fence to guide the piece for cutting a big tenon with multiple passes, and the other end gets a little wedge cut off. Then I align the hole positions with the existing holes and drill all the way through. Here fits a pin which allows the whole boom arm to pivot a little bit, and a bolt on the bottom lets me adjust that. Take a look.
Now this is the neutral position, and when here's a lot of weight, this arm will flex down a bit, and by tightening on this bolt, I can lift it back up.
I then made a nicer pin with threaded holes, and some more screws will lock the adjusted position of the arm. Next is the vertical part, which will be glued to the tenon. Here I jointed both faces and one edge, then drilled 2 holes. They will be important in a second. But first I cut the piece in half and planed both boards to thickness until their combined thickness matches the other part. Now I can stick another pin and drill bit through the holes to align them and cut both pieces to length at the same time. With the same technique as before, I created the matching joint for the tenon. Pretty cool method to create big, precise wood joints. But I actually did this for a different reason, because on the bottom will be another shaft, which I'll turn from an M20 bolt that I got for free as leftover material. It's grade 10.9, which means it's pretty tough, but shouldn't be a problem for carbide inserts. First, I needed to turn off the hex shape so it fits inside the headstock spindle. And I know interrupted cutting isn't the best for carbide inserts, but they are still cutting tools and I need that hex shape removed. Next, I flipped it in the chuck to again make a big center hole and drill and tap M8 threads. Then I chucked it with the live center for the main turning. The bolt has some wobble and I first turned the whole length until I got a continuous cut. Then I again marked the length of the accurate section and started turning down the diameter. Due to the threads, I couldn't quite reach my initial target diameter, but I managed to get the whole length consistent within 1/100th of a millimeter. Pretty cool. Then I turned the shoulder to final length, added chamfers, and turned the other side to the same diameter as the rest. And finally, I file a flat on the part for drilling and tapping M6 threads across. Now in an ideal world, I could cut a curved channel perfectly matching the shaft. But a trim router cuts a square channel and that also works perfectly fine. I added a second threaded hole in the shaft, transferred the hole positions into the wood and drilled through holes for the mounting screws. Ah, slotted screws. The best invention ever. Everybody loves them. And now the boom arm is ready to be glued. First one of the joint surfaces, which I let dry for an hour, then the rest. Again using the pins for alignment, and later I plug the holes with a dowel. This now completes the boom arm assembly. Then I greased the shaft and the bushings, slid it on, and secured it with a brass washer and a little cap I turned.
Oh yeah, it's taking shape. And despite this smooth movement and the big leverage, it still feels pretty solid here. Also reason why I wanted these close fits up here, because a tiny amount of play up here leverages to a lot of play and movement here. But like this, I'm pretty happy.
So now comes the last assembly, the parallelogram arm, which is quite similar to before. I cut all the wooden parts on the CNC router, Then again, need to turn steel bushings that precisely fit the second shaft, which shouldn't be a problem. First, turning the OD to a press fit in the wood, then cutting it off, and turning the ID to dimensions. However, this time I wanted to try something different. Grinding the ID to size with a Dremel tool. For that to work, I needed to rotate the tool post by a couple degrees, spin the lathe in reverse, scratch the surface, set a couple hundredths cutting depth, and here we go. I'm genuinely impressed how well this works, feeding all the way in and all the way out again. After 3 passes, I got this. A slip fit with 1/100th play. I couldn't have asked for more. I pressed them in and continued with the remaining wooden parts. As you may already guessed, these holes also receive a simple bushing. But this time I had a bit of a production setup. In the first setup I used the tool as a stop, then drilling the hole, finish the end with 2 light passes, adding a chamfer, cut the piece off, and repeat. In the next setup I used a spacer to position the piece in the chuck and finish the second side plus a chamfer. And then I opened up the hole with a boring bar to be the right size for reaming, since I don't have the right size drill bit for that. Now, why did I use 3 setups for a simple bushing? Well, I needed 32 of them, and they now all get pressed into the remaining wooden parts. These parts have location features machined into them and align the bushings and clamped together like this. The main shaft fits nicely, as well as the shoulder bolts. So then the same thing with glue again. Since nothing was binding up with clamps, I didn't need the rubber bands. And this also got some reinforcement dowels. For the parallelogram arms, I bought some square aluminum tubing at rough length. At the table saw, I cleaned the factory edge and then cut all of them to equal lengths. Well, it's better double check the length on the drawing. What the fuck? Each end of the arm pieces will get a reamed hole for then again a bushing and a shoulder bolt to rotate on. And to get this nice and smooth, I got some nylon bushings. But as you can see, these are not precise. Their ID is about 3/10 larger than the shoulder bolts. I won't accept this with the other tolerances of this project. So once again, I'll be making my own bushings. I use some POM round stock I have from a different project and again make some kind of a production setup. Register against the tool, facing, drilling, and reaming. Then I insert a precise pin I made to prevent the hole from deforming or collapsing while turning the OD. This stuff is a joy to work with. Beefy cuts to remove material quickly and lighter passes to reach the specific dimensions. And the best part is cutting it off. With the pin back in place, I chucked it the other way to face the shoulder to thickness and chamfered the edge. For a shoulder on the other side of the bushing, I also turned washers from the same material. So I drilled and reamed a deeper hole that fits the OD of the bushings and then cut them off one after the other. To repeatedly drill the holes into the arm tubes, I modified my vice jaw to install an adjustable stop and also pressed some small plastic pieces into the arm tubes, which will help when installing the bushings and keep the square shape over time. So then I drilled and reamed the hole to press in the bushing. And since I made this a slight press fit, the shoulder bolt no longer fits, so I run the smaller reamer through there again and make it a perfect fit again. The other end gets the washer, and that's it for the bushings. For clearance and aesthetics, I cut off the corners before I could do the rewarding assembly. So far, so good. It can't support a lot of weight at the moment because I haven't added springs yet, but this feels nice and smooth. There's no play in the joints. I can easily reach the ceiling now, and when it's fully extended, also the floor. And then I can fold it together nicely into the arm, just like I planned. I quickly made the camera mount from some hardwood, screwed it to the end of the arm assembly, and mounted my tripod head. Since I only have one camera, I have to simulate the weight for setting up the springs. They get hooked onto some pins, which I forgot to record making, but it was just some more lathe work. One replaces a shoulder bolt, the other mounts to an arm. And with the arm offcuts, I could clamp it at different positions and figure out the right tension to support the weight in every position. This required varying the spring tension and the friction in the joints.
With the springs now set up, it can hold the camera weight in the fully contracted position and the fully extended position, and also everything in between.
So then I marked the pin positions and drilled holes to install them properly. Now I can easily move the camera from one scene to the next and also high up in seconds. Just what I need to install the very important end stops on the rail. An angle bracket with some wood and felt. After that, I took everything apart again to bring all pieces to final shape, round over edges, and paint it with a very satisfying moment.
I quite like how the blue color came out. And now let me show you something you probably wouldn't have guessed. Yeah, I built this thing twice. The workshop has 2 rooms. And I could do some nice changes and improvements on the second build. I used old bearings on this and this joint, which saved quite a bit of time not having to make the bushings. But with the bearings, it ran so smoothly that it started rotating on its own. So I had to add some friction blocks pressing on the shaft, kind of acting like a brake. Now it works and is fully hidden. The other thing is, when this one is fully contracted, I can't rotate it all the way because it collides with the boom arm up here. Here I slightly change the geometry and will never collide. With only one camera, it's difficult to show or tell you what a game-changing upgrade this project is for me. And you will probably never see it again. But it works so well and will be incredibly useful for making new videos. And on top of that, it was a ton of fun making. So until next time, goodbye.
Hey guys, welcome back. So today, I'm working on this home light, 3000 watt generator. This one was given to the channel by Stanley. He found this actually at the dump. Someone had thrown it away after, I would say, a long time of storing it quite well. You know, this machine, I haven't quite placed the vintage on it. You know, I'm guesstimating about 1950. From what I can tell, this 2-stroke engine was actually made by Homelight during World War II. It is a model 24A, and they sold that engine all the way up to about 1970. Anyway, this has a lot of stuff on it I'm not familiar with, so it is going to be a challenge. I did take a look for spare parts online and came up pretty much empty. Couldn't find a user manual, never mind a service manual. So I think we're on our own on this one. Anyway, I want to check for spark and compression. This is a points and condenser, so I'm sure that's going to need a bit of work. But before I pull the engine over, I think we need to deal with what's going on in that tank. It smells really bad and is varnished up pretty severely. You know, someone left fuel in the tank, and the tank is not in very good shape. And in the off chance that the carb is any good, I don't want to pull the engine over and suck that stuff into the carb. So I think I'm going to start there. Let's just get the tank and carb out of the way. We'll pull the engine over, check for spark and compression, and go from there. Looks like there might have been a pre-filter at one point around here, which is long gone. The filter is still usable. Gonna have to be very careful here. This tube, it is very petrified. Usually I would just cut something like that off and replace it later. You know, in this case, I'm not so sure that's a good idea. Replacement parts, they're not existent. And also I believe there are some pickup tubes coming down from the carburetor into the tank, and I don't want to damage those either. So I'm gonna try to move one of these clips down, and then we'll see if we can pry with a screwdriver to release the carburetor from this tube. Actually, that was easier than I thought. I thought I was home free with this tank, and I can't get it off. Actually, the bottom of the tank isn't the bottom of the tank. Where the carburetor goes in on the top, those tubes go down actually beyond the bottom of the tank into what looks like some sort of a bowl. And that bowl is hitting this spring. So I can't actually get the tank out. So I think the best plan of attack here might be to remove that bolt for the spring, and that should allow me to get some clearance or move that spring out of the way just a bit to allow that tank to come out. This one's probably not metric. It's also not 1/2 inch. Actually, a 15 millimeter fits pretty well. Yeah, that wasn't too bad. So I'm just going to leave the tank and the carb over here for now. We'll come back to that later. For now, let's check for spark. So before checking for spark, let's just get the plug out so that way we're not fighting compression. And we'll also get a little bit of oil in that cylinder. You know, I have no idea how long it's been since this engine was started. Plug looks decent, no rust. Champion plug J-6J. Interesting. There's a little port on the intake manifold kind of squirting out some oil. So that is most likely an impulse line of some sort for the carburetor. So this might have a diaphragm pump on it, which I'm hoping it doesn't, because I'm sure that would be shot by this point. All right, let's check for spark. The spark tester has a 1/4 inch gap. So if we have strong spark, which I doubt we do, it should be able to jump that gap. So let me kill the lights. We'll pull the engine over, see if we get any spark. All right, I think that's enough with the lights. We still have a bit of light, but hopefully we can see that a little better. So I'm going to pull the engine over. This engine spins counterclockwise, which is different from modern engines. So let's see what we get. Wow. We've got spark. How? I'm not sure. Let me just pull the engine over one more time. Make sure we have consistent spark. And we do. Let's check compression. So on a 2-stroke engine, I would expect at least 120 psi. It could be higher, but any lower, and I don't think it'll run very well. So let's pull it over a few times and see what we get. One pull, we're at 110. So that's pretty good. And actually this cord, I would say, is a little short. So it's hard to get a good pull on it. But let's try a couple more, see if we can get up to 120. Yeah, just about 120 on 2 pulls. So not bad. I think it'll run. We've got spark. We've got compression. I say we add a little bit of fuel. Maybe plug a light in, see what we get. Let's give this a try. Put a little bit of fuel down the cylinder. I might squirt a little bit in here as well. I had wanted to hook up a light, but these receptacles, they're not like anything I've ever seen. I don't have anything currently that'll fit in there. So for now, this will just be a test of the engine. Nice. A little smoky in here after running for about 1 second, but we've got a runner. I mean, to be honest, I thought this was going to be more of a challenge to get running. It is such an old machine. First pull, started right up. So compression, no issues. Spark, no issues. Power output, that is a TBD. I do need to get some adapters so we can adapt this to something a little bit more modern. So I'm going to order those up. And I think while waiting for that to arrive, we'll just turn our attention to the tank and the carb, see if we can't save both of those. So I think I'm going to start just by cleaning a little bit of this junk off the outside of the tank. And then we'll pour out the contents, put some nuts and bolts inside, shake it around, and see what that gets us. I'm actually going to switch over to WD-40. A lot of this is just oily dirt, and WD-40 does a really good job of breaking that stuff up. This tank does not have a lip on it, which is good. It'll make cleaning it a lot easier. A lot of newer tanks have lips on it, so you can't actually pour everything out that's inside the tank. And there's a look at what came out of the tank. Definitely a good vintage. But not so much for running an engine. Anyway, we can now see the bottom of the tank, and yeah, it doesn't look great. So we're going to start simple here. We'll just add some nuts and bolts, a bit of water, shake it around, rinse and repeat. We'll do that a few times, and hopefully that'll knock a lot of that rust out of there.